In this video, we are going to discover what an industrial boiler is and how it works. But first, let us consider the term heat. Heat is vital in everyone's day-to-day lives. Whether it be heat to warm up our surroundings or heat to be able to cook food, we all use it to some extent in our day-to-day activities. Water and steam are great heat carriers and are not damaging to our environment. The boiling point of water at atmospheric pressure is 100 degrees centigrade, or 212 degrees Fahrenheit. By pressurizing the boiling system, by giving it an airtight seal, we can actually increase the boiling point. This is how pressure cookers work. An airtight vessel to increase the pressure, to increase the boiling point. This makes the food cook in a much shorter time than if an open saucepan were to be used. So how does this compare with an industrial boiler? Well, for a start, industrial boilers can cope with pressures much higher than a pressure cooker. Industrial boilers are often made by welding together thick steel plates, allowing extremely high pressures to be made. It has to be made incredibly strong to cope with the high pressure, as failure to do so will result in forces close to an exploding bomb. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new Real Parts videos. This way, you never miss another one. The function of a boiler is to either produce hot water or steam. Hot water boilers heat water for the purpose of domestic or commercial heating and hot water supply. Steam boilers generate steam in order to power turbines for power generation and various other industrial heating applications. To visualize the effects of steam generation using a boiler, think of the steam powering a turbine. When the steam passes through the blades of a turbine, the force turns the blades and accelerates the turbine. Steam contains an enormous amount of energy, so it makes the turbine quite efficient and, depending on the fuel used to boil the water, quite energy efficient too. There are different types of boilers for all sorts of different applications. We are going to cover a couple of the different types, including how each of the methods is able to generate heat, so you can familiarize yourself and be able to correctly identify them. Firstly, fire tube boilers. The typical makeup of this type of boiler is a furnace, a water tank acting as a boiler, and a smokestack. There are tubes running through the water tank carrying the heat from the furnace, and the smokestack vents the heat and gases caused by the heating effect so that the pressure does not continue to rise above the intended level. So, the fuel is burned inside the furnace. The tubes transfer the heat of the furnace through the water in the tank. Once it is heated, the steam generated is moved along downstream. Fire tube boilers tend to be the cheapest type of boiler to produce, as they have a fairly simple construction, but are typically limited for low to medium pressure applications due to the thickness of the outer shell containing the water. Now that we've covered the fire tube boiler, let's have a look at a water tube boiler. The design is fairly similar to a fire tube boiler, but instead of the furnace heating fire tubes to heat water in a tank, the furnace heats water tubes inside the furnace. In the same way, a fuel source is burned in the furnace, causing the water tubes inside to heat up. Once again, when the water is boiled, steam is generated and moved downstream. A water tube boiler is more thermally efficient than a fire tube boiler, but they are more complex to construct, and the quality of the water can be a limiting factor. the water may need filtering to operate most effectively. Combustion is the process of burning a fuel source. To create a reaction, there must be a fuel source, heat, and an oxidizing agent. Boilers can be designed to burn a specific fuel using any number of different technologies, but the main component to consider here is the heat source, or otherwise known as the fuel. The fuel is one of the most important aspects of a boiler, and is what burns inside the boiler to generate the heat. There are many different sources that can be used. Coal is a standard fuel source. In industrial boiler applications, the coal tends to be ground to a fine powder as it burns more completely than traditional bricks. Electric can be used as a heat source, either by resistance heating coils or electrode units. Electric would normally only be used for smaller commercial or domestic use. Electrode-type applications require very high water quality and conductivity to work effectively. Maintenance is key to electrode-type applications too, as cleaning the insulators is required to prevent arcing between the electrodes. Gas-fired boilers work by using either propane or natural gas, whereas oil-fired boilers work using gasoline or petroleum-based fluid. So let's now recap a few of the things learned today. Boilers are an extremely versatile and important piece of engineering equipment, not only for us on a domestic level, but at a commercial and industrial level too. There are so many different applications that boilers are used for. They are used in the food industry. Food at various stages of production needs to be heated or boiled as it is processed. Another interesting use of boilers is in the brewing of beer. During the beer brewing process, the malt needs to be ground and mixed with water, a process called mashing. This mash is then heated using steam for several hours before the yeast is introduced to trigger the fermentation. To generate heat, we need a fuel source. The reaction of having a fuel source, heat, and an oxidizing agent allows for a reaction to take place. This keeps the heat source going. By heating tubes of water and using fire tubes to heat a tank, steam is produced at extremely high pressures to produce enormous amounts of energy. Okay, that's all for today's video. If you've learned something new from this video, it would mean the world to us to like this video. If you can think of anything you'd like us to cover, let us know in the comments, and we'll see if we can put together a video on your topic too. Catch us next time for another informative video. That's it for now. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.